So we have spoken about the GPS. Now let's see what we need to go in the field and collect some field data. Well, first of all, the tools. Basically, we need two tools. We need the GPS receiver that we have seen can be different according to our, let's say, budget limitation and our purposes. So we can have a differential GPS, or we have as well normal GPS for, let's say, outdoor. And for sure, we need a tool to handle this data. And I will show you that there are several tools, several software. And basically, when you purchase a GPS, often there is its own software, but as well we can find in the web some free software, open source software, as well as some application to be loaded in a smartphone or in tablets. And you know that they are more and more common, and so it can be a nice idea to go in the field with the software on your smartphone and tablets. For Windows Phone, we have GVSync Mobile, that is a full GIS for collecting field data, and the most important features are the Special Reference System Management, support for shapefiles, GPX, KML, and many other software. It's a full set of symbols and labeling. It's capable of using for sure the GPS. We make select and query the collected data and the existing data, and we can access some web services, and as well we can edit and customize table, and you can download the GVC portable from the website I wrote down in the slide. We have as well another software, another app for Android. It's called GeoPaparazzi, and through this application we can georeference notes, sketch images, and as well we can track GPS logging. We can use online or offline maps, so it's very important because maybe you cannot have your online connection when you're in the field. It's very easy to export the collected data, and it's a map view for navigation of the environment. So what is the basic of surveying? What is positioning? Basically is where is what and where we are, and what we need is to know the coordinate system. So how many different coordinates a single point could have? We can have many coordinates even if the point is the same, because every reference system brings a different coordinate for the same point, written in a different way even if the point is the same on the ground. And a surveyor, when a surveyor gets coordinates, the first question must be what's the coordinate reference system for this coordinate, even if then we can reproject and we can shift from one system to another. It's very important that the surveyor since the very beginning knows which system he's going to use. So we see that the main points, I'm speaking about Jordan, Aqaba, if I use the geographic coordinates in degree has values, we have seen already this information, while if I use the UTM, the plan coordinate system, the same point has a different coordinate system. So basically it's very important that the surveyor, before going in the field, knows which system is going to use and perform a GPS setting. How we can survey? We can survey a single point. So we see that maybe we can go through our lines and collect just the corners. Then in the office we can rearrange this shape. It's a very good system if we have huge straight line that maybe take time to take all the line, because maybe there are some kilometer of straight line. So we can take a point and move with the car along the roads, let's say, and then if this is a straight line, and then take the other point. For sure, let's say it's less precise, but it's less as well time consuming. For sure, we can also take tracks. You see, the surveyor can move along the perimeter, and for sure you have a higher precision, but as I told you before, it's more time consuming, so you have to select your methods according to your needs. Remember that when you survey, maybe you have not the possibility to survey the exact point. We have seen that there are some constraints, some limitation. So in this case, maybe the surveyor cannot go to the trees and collect data. So there is some Kogo suites of programs that you can find for free on the web that is used in civil engineering for solving coordinate geometry problems. So you can get points through lines, intersections, circles, alignments, angles. Let's say in this case, the surveyor cannot go in point 5 and 6 to collect data, so he goes in point 1 and 3, takes these coordinates, take the distance, and you see in this case the point could be 5 or 6. So as well he has to note if there is right side or left side of point 3 and the same for point 1. So after having taken this information, then in the office through the software that I repeat you can download for free, you can derive the exact positioning of point 5 that was not surveyable directly. So as I told you before, you have to take care not to positioning your survey so closer to phone antennas, for example, so any electromagnetism component can disturb your survey, even if your GPS maybe can be able to screen the received information and maybe remove the noise. As well, you see that in this case trees, walls and tall houses in narrow streets can disturb the survey. In some cases there is a longer antenna that can go higher than the walls, and so maybe you can use this longer antenna to collect right data. Otherwise you can use the Kogo system. Which also, as I told you before, this tool Geoparazzi, that is a smartphone app for Android, and it's very high customization. For sure you need a GPS. In this case this will become green, and when you go in the field, when you download, it downloads as well this tool. That is a nice tool to see if you have how many satellites you have, your precision. Remember we have spoken about DOP, HDOP and BDOP. So you have all the information about satellites over your head and how many you have and the intensity of the signal. Here when you go in the field, you see that you can also download your own map, or you can use the online one, and then you can take some image note, some text note, some sketch note, so you can get many information, and you can customize as well your field note. Then once you have exported, you have finished your data collection, your photo and your notes, you can export what you have collected into KMZ or GPX. In next video we'll see how to manage this information, but I can tell you in advance that have a look, if you export like KMZ, that is a Google Earth format, you can easily upload into the Google Earth services, and this is the effect. Let's say you have just, in this case, just the description and the picture, and you locate this description into the Google Earth services, as well through another open source software, Stage, that you can download for free. You can convert a Geoparazzi project, so I mean the information and the link to the picture, into a shapefile, and then for sure you can import or you can load the shapefile into the GVSig. Thanks so much.